Alright, so
Today's Wednesday, yeah? Wednesday is the 31st.
AP Calc, and last time, guys, we were getting towards the derivative.
Wait, Grace, you grab me one?
Yeah. And most of us know derivatives. Because we did that. But yeah, or like, if we go over it, like, that's why I said.
I'm not going to skip on the derivative, the most fundamental aspect of calculus.
We're
definitely going
We're
into
not
the
talk
derivative.
about tangent yet. Tangent right.
So, where we left off last time was talking about the secant line versus the tangent line. Secant line touches a function at 2 points, and tangent line touches a function at 1 point. Okay. So the slope of the secant line provides the average rate of change of the function between 2 points, and the slope of the tangent line provides the instantaneous rate of change of the function.
We're talking about that. That was where we were like.
Sad looking going in here. So. You guys don't say something. Okay, so how do we get this? How do we find the slope of how do we find the instantaneous rate of change of the function? This is basically the essence of differential calculus, or more specifically, the derivative. So, let's do visible. Let's go to
They made a sense sign for a reason. Why would they not have it? Graph paper. Hello. I do.
I wish I could just press a button and X, Y grid. It may exist though. Okay, so.
I want to pay.
You guys are familiar with the terminology when you hear let y be a function of x. You may have seen that a lot of times in textbooks. Let y be a function of x. Right. So let's go with. We usually do blue. Let's go with purple.
I want to do pink. It's not blue.
Let's go.
That's the amount, not pink.
This is section 2.4, yes. I don't like the way the book just doesn't say, this is the derivative.
Okay, so. Alright. Let's pick points on here.
Oh, purple. I love purple.
So let's say, what do I want to do? Let's choose here. Let's choose here. This point here and say this point here. Okay? And you guys would know, say,
I love blue too.
let's call this point X. And so any value, I just happen to pick this particular point. Yeah, so X. And then we're going to call this point here, or I should say the X coordinate of it, X plus H. Okay, so this distance here would be what?
H.
That would be H, right? Okay, so if this is X, how could we write the Y coordinate for it?
Why?
No. What would it be? So this is X, and I'm saying, think of this as the function. Let's say, let this function be f of x. It's very common. Like that. So f of x. Okay. So this is x, this would be just f of x.
So why couldn't we use y?
You could.
Oh,
But I want to have everything in terms of x.
okay. Sorry. No, feel free to kick me. I understand.
You're not gonna kick you. They might do that. Okay, so then what would, if this is x plus h, and h is just some distance, okay, what would we say the y coordinate is?
F of x plus 1 plus, sorry,
Plus
h.
h.
F of x plus h, right?
But it's not, we don't know if it goes up as far as it goes over. Does that make sense?
It's not saying like.
Oh, I see this distance, so the gradient could make it go farther up than it did over, so that.
It's
this
just
one-
saying like, it's just saying, think of x plus h as a number, like x plus h is 7. It's just saying the function of 7, like f of 7.
But
which
do you
is-
understand what I'm saying? Like, even in the graph, h is technically 4 units, and there, h is only 2 units.
But you don't have
They're not saying
parentheses. It's not saying add h, it's saying
That's
f
what
of
you're-
x
it's
plus
not
h
like
is
There's nothing
x plus
necessarily,
h.
there's nothing saying that, if this is a distance of 4, that this has to be a distance of 4.
No, I get what you're saying about like the points or whatever. I'm just confused because like the way I look at it, h is the distance, even though like I get what you're saying with
Yep.
the points. It's just weird because that h is bigger than the other h, even though it's not.
Well, let's be careful. This is f of x. This is f of x plus h. This is x. This is x plus h. Two different things.
Because you're plugging f of x, you're plugging something in. So you have to consider when you're plugging in x plus h, that's going to equal your y value.
Yeah.
That's what it's saying.
You may. I mean, a very simple. This kind of looks like a cubic. So let's do a very simple example that kind of goes along with what you're saying. So, like if I had, say, let's say f of x were equal to x cubed. Okay. Well, let's say we go f of 1 would be what? 1, and f of 5 would be 125. You know, I'm only going in terms of my independent, you know, is going to, you know, distance of jump from 1 to 5 is only 4, but this is a jump of 124.
Yeah, that makes sense.
Okay. So, all right, so this is just, this is here, so we say, okay, everyone agrees on this. So how could we write, say, between these 2 points that I have labeled here, how could we write the slope of what would be the secant line using these terminologies here?
The change in line or change in x, so it would be f of
Yes.
x plus h minus f of x.
Yes. Good.
Can we say that one?
So, yes. So remember that slope is different in y's or different in x's. So let's do it from here to here. So we say f of x plus h. Okay. F of x plus h minus f of x all over x plus h minus x.
Do you have to put x plus h in parentheses, or you just?
Oh, we could. Don't have to, but we could. Maybe makes it a little more clear. Okay, so you guys pretty much agree that this could find the slope of any function f of x, regardless of what the function is. This would give you the average rate of change, aka the slope of the secant line. Difference in y's over difference in x's. Okay, so let's take. You
The
see this?
secant line is just a straight line that goes through those 2 points.
Yep. So now, what they had, it wasn't until Newton came along and they wanted to figure out, okay, how can we find? Is it possible to find the instantaneous rate of change in something? Is that possible? And Greeks couldn't do it. No one could do it before Leibniz and Newton came along. Okay, so basically, let's imagine that this point, we trace it and we get closer and closer and closer. We drew another secant line, right? And we pulled even closer and drew another secant line. See how we're getting closer and closer to this point. We would be getting pretty darn close to what would eventually be the tangent line the closer and closer they get, and we keep applying this formula, right? It would still be the average of change. If I'm getting closer and closer, just give you a mental picture of what's going on. This is what they're trying to figure out. Like, okay, how can we get them really, really close? How can we get them really, really close? How can we do this? And if you guys now kind of have an understanding of limits, and what is a limit?
Approaching.
The limit is the value that we are approaching. So he's like, so I don't know if it was Newton or Leibniz, but one of those guys, they said, well, why not have this distance approach 0? What would be the limit or the value of this as this distance approaches 0? And that is the derivative.
Okay.
And what about if I just,
So the derivative is a limit. And I'm going to write it out clearly, but it's going to include this guy. This guy, by the way, your textbook will call it the difference quotient. I don't care the fancy they calling it the difference quotient. I don't care.
Sorry, with eighth, it was like a whole other vocab test in this year.
Right. So this is American English. So the difference quotient is what it's called. So the derivative is if all I did was say take the limit of this whole thing as h approaches 0, and that is the derivative. And I'm going to write that on the next page. It's going to be the whole thing because it's so important. It's going to take up the whole page. So let's do, not because it's complicated, but I'm going to emphasize it. I'm going to take up the whole page.
Isn't it just to find the slope of the curve?
Is what to find the slope of the curve.
Derivative, right? Yeah, that's what we learned, the derivative as, like a simplified.
That's not very clear to me. The derivative is the slope of the tangent line at any point on the curve.
Yeah.
okay.
That's a more clear way of saying it. You say the slope of a curve, well, a curve is curved. But if I say, okay, if I took a tangent line,
On a certain point.
if I, let's say this point and took the tangent line, the slope of that tangent line is the derivative. So then let's write the definition of the derivative. So, not this. So, what color? Black?
No.
Brown.
Oh, why?
Do I have a problem with brown?
I want to go with a different color and actually write it.
Blue. Pink.
Was it standard blue?
No, the
What is
pink.
the two pretty blue?
Pretty blue.
I don't know if we're gonna do one for you. That's the lighter blue. They're both pretty, but the lighter one's better.
We
That's pretty.
teal. I call it. I don't know if it's teal. I call it teal.
It's like a sand.
Let's go with the blue.
Take it
Blue's,
from the orange,
blue's
and it's
dark.
aqua.
I like it. Let's go with the
Dear.
blue. So,
That one's not
so
gonna be.
we say that the difference quotient, or to find the average rate of change, we all agreed, I showed it to you graphically, was this.
Yeah.
Okay, and the derivative I showed you, let's shrink that x, let's see then what would the value of the difference quotient be if that distance was approaching nothing. So the limit of this as that distance h approaches 0. This is the derivative. Now, not to sound redundant, but it's an important fact that we must understand. The function for which we take the derivative must be a function that is differentiable, and we'll talk about more about that later.
Now, when we're doing the derivative, are we going to be seeing this format, or will it just ask differentiate this function?
I will expect you to use this.
Yeah.
And we'll get to the shortcut, which you guys may already know. I don't know if you've studied.
We would flip it, like if they were like, if this was a fraction, we would flip this stuff on top and then just use we carry over the exponent and multiply and then compute.
What are you talking about?
Okay, don't worry. We're going to. Okay, so you sounds like you may already know the shortcut.
Yeah.
Okay. So, okay, you guys know the shortcuts. Now, here's the problem with this that I've noticed with students is they'll learn the shortcut, which is great, especially shortcut. We're talking about for polynomial functions. It's great. Just reduce, bring in the front, all that. And if it sounds like garbage, don't worry, we're gonna go over it anyway. But those are the shortcut. Okay, that's great. But what I notice with students is 3 months down the road, or 1 month, even 1 or 2 months down the road after they've been using the shortcut, they forget this.
Yeah, we never.
But I want to forget.
The shortcut.
But I'm just telling you a typical scenario. You teach it this way. You show the shortcut.
Why is this important?
Good question. The reason that this is important. The reason that this is important is because it gives you an understanding of the derivative. It therefore just doesn't become some shortcut and you just, oh. And even a better answer to that probably you would appreciate more is because when you take the AP Calc exam, they will be doing things in this raw format. Problems will be in this raw format. And the problem is students that like to do the shortcut, which of course we love to do shortcuts, they tend to forget the underlying principle of this. Okay, back when there were no computers, back when there was no electricity, you had a guy sitting, outside or inside, depending on the day, working on things, and they were able to develop the derivative by hand. And it's on the AP exam. They expect you to understand the limits. That's why it's important. So, obviously the bottom would reduce to what? It would just be h. When I teach this, I like to be crystal clear and do it this way because it's very clear. And instead of just writing h, because you're going to see it, they're not going to leave like this. You'll see it just over h. But if I left it, when I left it like this, it made sense because you saw this was x plus h, this guy was x. That's why I just left it like that. And then you guys will naturally see the very simple simplification that it's just in the bottom is just h. Okay. So moving forward, you guys can just write all over h, but this keeps it crystal clear. It's matching components. It's okay. It is the difference quotient. So again, for terminology's sake, this part is called the difference quotient, but when we do the limit of it as h approaches 0, this is the derivative. I don't want to alter this slide at all because it's perfect. I really don't, because this is it. This is the heart. This is the heart of differential calculus.
Your limit looks really pretty this time. Your limit sign.
Yeah, I made sure for this particular one. I'm like, okay, this is so important.
You should put this at.
I'm gonna actually do the little whole end. Yeah. And do it this quickly. Yes.
Could you show us an example of actual numbers?
Yes, I will. We'll go into that now. So. Okay. Let me show it to you strictly algebraically. And pretty much, actually, seeing this, I think you understand it graphically. Yeah. For any sort of polynomial function, no matter how many ups and downs it has, you pick a point, the limit is basically, okay, let this point get infinitely close, the slope of the tangent line. Okay? So, let's do something, let's do a polynomial example. So let's say we have, I'll make it up. The example is f of x is equal to, and I could say y equals, f of x equals 3x squared minus 2x, whatever, random, okay? You guys know what this is, it's quadratic function, so the shape is a parabola, concave up, yes? Okay, so let's say I wanted to find the derivative of this function. So let's go ahead and do that. Okay, for those of you that know a shortcut, I know it's really nice and convenient, but we are going to be doing it for at least a few weeks. It's going to be a long way. Okay, and then we'll bring it up again before you take the exam, because of course I'm going to be showing you we're looking at actual problems from the exam. You're like, oh wow, they do expect a deep level understanding of calculus, because you just use a shortcut. It doesn't mean anything. You would agree with that. After a while, it doesn't really mean anything. It's just it's the process. When it's not, of course it's nice. It saves a lot of time. Okay, but let's not forget what the actual limit is, how it works. So let's do this. Let's do the limit as h approaches 0, and I'm gonna write it out the first few times in raw form because it starts to help with memorization. So let's do that. It's always good to do that. Are you guys fine if I just write h, or do you still want me to do the x's are gonna be the x plus h minus x? The x's will go away, so it's just h. That distance between them that I showed strictly in the horizontal, as that goes that change rule goes to 0. Okay. So let's go ahead and do this. I'm going to shrink this a little bit so I can put it on one page, more on one page. Not a lot of you in this class. Bridget, are you getting this? Is this making sense?
Yeah.
Okay.
And it's like we missed like 3 people, the entire class is gone.
Yeah, that's what they were small classes.
Let me ask, I didn't really, you guys are very vocal, but anyone not understand the concept I've explained so far?
Well, those of us that took pre-calculus would never get
Do you understand what I've explained so far?
I don't know.
Don't worry about the shortcut. We're going to get to the shortcut. But what I've explained to all of you, the limit, does this make sense? Understanding intuitively? Okay. Okay, so let's go from here. So f of x plus h. So f of x is this. What would f of x plus h be? What do you guys think? Hold on, sorry. I need to hold this up. I don't want to go that way. Okay, so let's keep going. So it's the limit as h approaches 0. Don't forget to write that we're finding the limit of this. Okay, so f of x plus h would be
3x squared minus 2 plus h.
Wouldn't be 3x minus, or x plus h squared.
mm-hmm.
So,
Keep going.
minus 2x plus h. And then it would be
In
minus,
parentheses. Yeah.
and then minus.
And I'm gonna
x squared
just to make it
minus
clear,
2x.
I'm gonna associate this, and then
Well, okay.
now we're doing this part,
It's like you just plug it in.
Oh, okay. Gotcha.
and then f of x. This is f of x.
Yeah.
I don't want to get too off topic, but I'm very curious. You guys studied parts of Calc 3, but you never went into the definition of derivatives.
She literally gave us like a thing and then said like multiply the exponent, like taught us the shortcut. And then we were like, oh, well, what is the derivative? And she explained the whole slope of the tangent line, and we got that, we understood that, but that was like the end of it.
Like we never used limits to find it. We always
Yeah.
just did.
Oh, okay. So yeah, this is huge for you guys.
And how to get it, but not how they're related.
Oh, okay, yes, this is huge for you guys. Okay.
Like
So
we understood what it was, because she explained the whole tangent line thing, but we didn't like, it was
How you got it.
you didn't
Yeah, we didn't understand
find the derivative of this.
using this.
Using
Yeah, we
the
understood the shortcut and
fundamental.
understood what it
Well, that's why we're
was.
all like,
Yeah,
because
we're
we're
like,
Okay.
let's use more.
All right, so let's go ahead. Let's work this out and see what happens.
I didn't even know that was true.
You guys that know this shortcut already know what it is, but now you're gonna see. Oh, okay, yeah, okay. Okay, so let's do this. So let's make sure our algebra is still good here, which is really because that's really what's gonna test here. Okay, so what is this? So we have 3. Let's go ahead and expand everything. So x plus h squared would be x squared plus 2xh plus h squared. I distribute this guy, I'll go ahead and do that now. Minus 2x minus 2h. Distribute the minus 3x squared minus 2x.
Plus 2 because that
Thank you. Just making sure you guys are paying attention. All over h. I wish this thing, if you guys know how, it would just let me select this, say just that, which sometimes it doesn't. It like automatically does this every time. Do you guys know how to like? It's okay if you don't. Okay, so I should know, but I was training. No training. Okay, so
Yeah, you have to be trained in how to use it.
yeah, I'd be training. Yeah. I'm doing pretty good for no training. Okay, so now we're here. So just keep going, keep expanding, distribute the 3. Try to get away. I forget this is where I'll get sloppy. You guys know it says shorthand LIM is limit. At h approaches 0 plus 3x squared plus 6xh plus 3h squared minus the same thing. 2x and that's minus 2h minus 3x squared plus 2x all over h.
So where do
I
I
don't
use-
like how close this is, but I think this is still pretty clear, guys. Like this is not. You
Yeah.
guys see? Okay, each line. Okay.
I think that reduces to 3h squared plus 6xh minus 2x.
So let's see. So
Yeah,
you guys see?
That's 2h, yeah, and then
Yeah.
2h. And then the 2x's.
And we're good.
Is
Okay.
it always going to cancel out like that, or do you have stuff that?
If the function is yes, yes.
What now?
Okay. So what now? So basically for all polynomial functions, this is all going to work out the same way every single time.
Fun.
It is fun if you like doing algebra. If you like doing math work. Okay, so I have run out of room. I don't think I want to make this any smaller.
Why don't you just make the bigger ones smaller?
I don't know if I can. Like, which one do you need? This guy?
Yeah, like that one, or
It
the ones
gets
below.
really, it gets really touchy.
Yeah, there.
It's not everything. That's good age. I know it. But uh-oh.
I think it's
Uh-oh,
what you
let's see how it
put it
looks.
over.
Oh no! It's just doing what I want.
And you can like pull it over to the side if you want.
Yeah.
You can probably put one in blue, I don't know if it'll show up or
X
not.
values, yeah.
See if you can pull it over onto the blue or something, that might help.
But it's blue.
Pull it over. No. I don't want it because I'm probably gonna have to end up sending you guys. I do want to. I will send you guys this. It cuts off the PDF. That's another thing I need to remember to do is if there's a way to make all this white so that the PDF would be like landscape, like when you print paper landscape, that'd be preferable, I think. But anyway, yeah, I don't want to cut it off. So, and this guy could probably shrink down a little bit.
Can you put it in the top corner, the upper corner?
Yeah, that's what I'll do. I'll work down here. So, beautiful. All right. So now we have we have the new. Let's go here. We have the limit as h approaches 0. Now this guy's gotten a lot more simple. We have 6xh plus 3h squared minus 2h all over h. This is where factoring, remember I keep emphasizing the advantages of factoring. So is there a common factor in the numerator? Yes. There is.
Well, there's a 2h.
No, because we're not.
The greatest common factor is h. Yep. So let's do that. So we have the limit as h approaches 0 of factoring out the h, 6x plus 3h minus 2 all over h.
Yeah.
Oh, I changed it. That doesn't matter. Let's do it. Right? This would go to, of course, a 1 and a 1. Just divided by h. They cancel. This is like that's that concept of the removal discontinuity kind of thing. So it's just a hole kind of thing, right? So now I can actually just plug in 0 for h to actually would give me the value of the limit, right? It's kind of like one of those things where, okay, there would be no analysis, I don't want to get confusing, but yeah, there's no point. H can't be 0, but we don't care. We only care what the value is of this as h approaches 0. This is why it's so important, that approaching thing, that approaching concept. You're allowed to do this when you're evaluating limits. If you have removable, call them removable discontinuities, I can now just plug in 0 for h.
Why?
Because it's a limit. Because it's a limit. It's not, it's not saying like, let h equal 0. That's different. Limit is what value something is approaching. As something approaching. So as h approaches 0, if you can remove it, that is fine. That is acceptable. Then you can just plug in 0, and that will give you the limit.
I don't get
The
that.
derivative is
Well, like I understand like
It
what
may
a
be-
limit is, but like why just because it's removable, why does that suddenly allow you to plug in 0?
Because of the way that it's similar to like, remember the one where I had like a hill, looks like a hill, and then a hole at the top of the hill?
Yeah.
That's what you have first.
It's like, you know it's being, let's say that value wasn't, say, I don't know, 10/4 or whatever. You know it's being a 10/4, even though at that point there's nothing. But the value of the limit as x approached, let's say it was 3, it was 10/4, that's all that really matters. Remember when we removed that? This is good. So remember when last class we removed the discontinuity? We found out what it actually was at that point. That's kind of the same process here. It's kind of it's a similar process.
This is what it would be if h was there.
Yeah, 'cause
So there is
remember-
no h.
Remember we
So-
did, where was it? Did I just extend the lesson?
Did I use the restroom?
That's fine, that's beautiful. So this is the same concept. You may use the restroom, yes, the pass is on the light switch, or near the light switch. This is the same concept as once we found, remember we did this and then we plugged in 3 to see what the value of that hole is, so to speak. And it ended up being like, was it like 10/4 or 10/3?
10/3.
Was it 10/3?
Yeah.
Okay. Yeah, exactly, 10/3. Same idea. Same idea.
Alright, so we're finding the value.
So now let's actually plug in 0 for h. So we would have, it would equal, I'm no longer going to write this part because I'm evaluating it right now. Before I was just doing expansion and combining like terms. Now I'm actually going to give the value of the limit. 6x plus 3 times 0 minus 2. So 6x minus 2. And for those of you that know the shortcut, you see it.
No, it's minus.
Oh, minus 2.
I've been there, done that.
Were we taught to put plus h at the end of our answer?
That was integral.
That was
Oh,
how
I was gonna say, whenever
Plus
there's
no variable, then
Okay, so you just said that. That would occur if you just simplified the difference quotient, which is without this. You just did this. You would stop at here, 6x plus 3h minus 2. But when you do the limit of h approaches 0, then you can do that and go here to find the actual
You
difference.
said the terms basically, when you didn't even plug it in. And that's the same with integration, right? Like when you have the brackets and it has like from
From that to
4,
that.
and if you don't have that, then you have to get a k. Okay.
it's
I'm
okay.
not gonna
I
lay
think
this to integration right now because
Sorry.
It was, we'll
it's
take
okay.
it.
It's
Well,
okay.
my question, like, I got very confused. I was back.
Yeah.
That's why they were saying integration. It's okay.
We're good.
Yeah, we're fine.
Okay.
The head put it on.
He says weird or what in here, it looks like French or something. Sorry, continue.
Okay, so we would say that, I'll write it right below it.
Just like, oh my god.
It's in your head.
There's like 2 steps.
Yeah.
You write it and then you do it.
Yeah.
But this
exponent for the coefficient, so 2 times 3.
So this is a notation that is new to some of you. This is, we would read this as f prime of x is 6x minus 2. Another way to read this,
So it would be 6x minus 2. So yeah, it's a super simple.
I'm going to actually do just show both. This was the value of the limit, so then therefore you could say if f of x equals 3x squared minus 2x, then this just means, this is new notation for you guys that have never studied this before, the first derivative of f of x is 6x minus 2. Or you're going to hear me say things like f prime of x equals 6x minus 2, which is another way of, there's a lot of different little notation things. So I could say the first derivative of x is 6x minus 2, or I could say f prime of x is 6x minus 2.
So you can do that again, technically it is 6.
And then she would do the- I don't ever want to.
I've never even.
Isn't, for those of you that know the shortcut, it is kind of neat, like how it magically works for polynomials. You just do this, bring the power to the front, drop it down, which you guys will see the shortcut very near
Figure out the
future.
shortcut was a genius.
Seriously, thank God for that person.
Yeah, I know. I would,
I would be very surprised if it was not the same person who
I know, oh my God.
developed the
I would not have finished. Already did finish, but would not.
I think I wrote down, I think I wrote
I
something down.
skipped some,
somewhere.
but I finished the ones I knew how to do. But I skipped like 4 or 5. Maybe 6.
Weren't there like 6 problems?
Yeah,
No,
like,
7.
I skipped
like
5
4 or 5 or maybe 6.
Did like parts.
I couldn't eat, guys.
Do you guys know off the top of your head which input it is typically for this guy?
Oh no.
I think it's the VGA maybe.
Just try to
There won't be a
find
point
it.
on Friday.
Source might be easier. Yes, you may.
Honestly, they have that like week before you go back to school for training for new teachers. They should teach them how to use this. I mean, how much time you would save in class?
Well, they have trainings when they originally got them, but if you didn't go to them, it's not like they continually have them when they're new teachers.
Wow, that's weird. It's the first time seeing that. Wow, okay. First time for everything. Okay, so how do I zoom a view? Do I manually?
There's a button somewhere on the thing.
On the top,
There,
there's
right there. Just try a
The one that says zoom.
You gotta focus it too.
Okay. Fill the lamp, you say?
And then you can also focus it somehow. There's
Like an autofocus button somewhere.
Ah.
It's really just
Why would I turn the light?
because it's making like.
It's a constant light, yes? Sure, it's something simple.
I'm sure it's
I'm sure it's something, a little technique to it.
Do you want me to turn on the front light?
I think you can turn off the
Turn off
top lights at the end.
Yeah.
like
Turn them on?
like teachers turn
Oh,
off. Always gonna
okay,
record.
okay.
I'm sorry.
Hopefully not.
Can I pass the lamp?
Beautiful.
Ah, there we go.
Here's the problem on the AP Calculus exam.
How do you find?
Which I wish was more clear. Okay, so.
That might be the
Isn't there a lamp, a light?
Yeah, there is a light on that.
I got it.
No, we're good.
I think I have it.
No,
I
like
hope I have it.
even
I hope I have it.
beyond the autofocus, is there like a focus?
Oh, darn it. It's too bright again.
What's happening?
What?
Close the windows?
want to ride it on the board.
Like I had nothing else to say. except that.
I think there's a way to change the light.
Yes, okay, that's such a good idea.
Right? Okay, good.
So exciting.
And I'll be.
You're changing your camera too.
If my parents.
Turn off
If
the
I
alpha.
God bless America. Why is it so difficult?
What?
Where's the paper down?
Oh yeah, there. Keep going. Yep. Right
Did we
there.
get it? Did we find? No, too
Is
far.
there like a brightness?
Right there.
How does this work?
Why is it not
You
just
can almost
clear?
read that.
I don't know.
Why is it just not clear?
Maybe ask.
Can everybody read it?
I can read it.
Yeah, okay, we can all read it, we're good.
The limit of 7x minus sine of x over x squared plus sine of 3x as x approaches 0. Just all I am showing you
Three.
is there are limit problems on the equal exam.
There are three questions on the exam.
If it's multiple choice, I got this.
Some of it is, other part is fill in response.
How many questions?
I was gonna go over this in that paper.
There's like 10 questions.
On this. Hey.
I finished my dance article.
Already?
Yes, I did it yesterday. I did, I did 2 assignments for econ, 2 assignments for home. I did my lit homework.
I did that though. I did 3 assignments for history.
Here's the breakdown.
3 for Spanish. I'm like,
I was going
We already passed it
to.
on to you.
I had to do a lot for each of them. Like run a mile.
Oh no, I skipped 2 assignments to go to the next one.
There's gonna be A's all over
Great
again.
jokes. I called my teacher and he sounded surprised. He was like, "You're not in my class." I was like, "I am."
Wow, this is.
I was like, "I am though." Talia. 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 Thank you.